Ionic and covalent bonding aren't the only types of associations between atoms. There are also metallic bonding and hydrogen bonding. These two do not result in the creation of new compounds like ionic and covalent bonds, but they do hold atoms together. Metallic bonding holds metal atoms together, and hydrogen bonding pulls molecules with hydrogen in them together. Metallic bonding occurs because metals are usually very dense substances, meaning that their atoms are held close together. Since the atoms are held so close, the electron clouds can actually overlap, which allows the valence electrons at their edges to actually jump from one atom to another. The valence electrons in a sheet of metal can in essence flow freely throughout the entire sheet. All the metal atoms in the sheet are now metallically bonded together. This is why metals are so hard to break. Since all the atoms in a sample of metal are essentially bonded together, and since valence electrons can move freely around the sample, metals have several unique properties. Metals are conductive, meaning that an electric current or heat can move through them easily. Since valence electrons can move freely through the sample of metal, sending an electric current, which is just a stream of electrons, through it doesn't cause an issue. Also, due to metallic bonding, metals are ductile, meaning they can be drawn out into wires or stretched a lot without breaking, and malleable, which means that they can be hammered down into different shapes or flat sheets. Basically, metals can be bent into any shape necessary and can be used to direct electricity. They're also usually lustrous, meaning they shine. Hydrogen bonding is often referred to as an intermolecular force rather than an actual chemical bond, because it holds molecules near each other rather than bonding atoms together. This happens because of the properties of hydrogen atoms. They are the simplest atom, just one electron and one proton each. It is the only nonmetal on the left side of the periodic table. When atoms from the left side of the periodic table bind with those on the right, usually you get an ionic bond, but when two nonmetals bind, you get a covalent bond. When hydrogen bonds with other nonmetals, we call it a covalent bond, but it actually kind of blurs the line between covalent and ionic. When hydrogen binds with an atom like oxygen, as it does to form water, it shares its electrons with the oxygen, and the oxygen shares one of its electrons with the hydrogen. But because hydrogen is so small and has so few protons to pull on the electron, the two atoms don't share equally. It's kind of like if you and your older sibling got a new computer, but you had to share it, so you worked out a schedule where your older brother or sister gets it on the days ending in a Y, and you get it on all the other days. Theoretically, you are sharing, but not really. Since hydrogen kind of gets bullied into losing one of its electrons, it now has one proton and may or may not have an electron. So it now has a positive charge. The other atom now has more electrons than protons, so it develops a negative charge. Altogether, the molecule will have one end that's positive and one end that's negative. This is called polarity. These polar molecules then act like magnets, with the positive hydrogen side of one molecule being attracted to the negative side of the next molecule, and the positive side of that molecule being attracted to the negative side of a third one, and so on. Water, like all compounds with hydrogen bonding, has some interesting properties, which you may have noticed before that it gets from hydrogen bonding holding its molecules together. First, water is adhesive, meaning it tends to stick to other objects. If you've ever seen a drop of water stick to a window, you are observing adhesion. Second, water is cohesive, so water molecules tend to stick together. If you suck on a straw, you're only pulling on the top molecules in the straw, but the ones below it and farther down into the glass stick to those you're pulling, so the straw stays full and you can keep drinking. The third property is called surface tension. Since water molecules tend to stick together, they also tend to form a rigid surface at the top of the sample of water. Water forms droplets because that surface holds it all together. If you have ever filled a glass all the way, you may have noticed that you can fill it just a little above the top. That was surface tension holding it together and keeping it from spilling over the sides. Some insects can walk in water because they spaced out their weight enough not to break the strength of the water's surface. Since these are just intermolecular forces rather than true bonds, if you add too much weight or add too much water to the glass, the surface will break and the water will spill over, or that insect will sink. These three properties together make capillary action possible. Capillary action is why you can hold water in a straw by putting a thumb over the top. Some water sticks or adheres to the sides of the straw, other molecules stick or cohere to these molecules, and some form surface at the bottom, keeping it from spilling out. This is also how plants, whether they talk about a blade of grass or a 300-foot redwood, get water from the ground to the leaves at the top.